Welcome, welcome, everybody. Hello, hello. We are so very happy to see all of you here today. I am recognizing a ton of names. Welcome back, everyone. So glad you could join us. Hey, Nancy. Nancy is just kicking off our introductions in chat. If you'd like to go ahead and introduce yourself in chat, that would be awesome. Please do so. We'd love to know where people are joining us from. So you do not need a microbit today, Nancy. That is a great question. Chip is going to show you some amazing places you can practice with microbit without having the hardware. So, oh, excellent. Well, welcome, welcome. Thank you for joining us from Cambodia. I do not know what the time difference is, but we are very happy that you could come today. So thank you. Excellent. Hi there. Hello, everybody. Let a couple more people in. All right, we have people joining us from everywhere. Idaho, Cambodia, Phoenix, Colorado, Indiana, Nebraska. It's 11 p.m. Thank you. Thank you for coming. It's going to be very late for you if you hang with us the whole time. Excellent. Hey, Lisa. Lisa's joining us from North Carolina. Awesome. You're going to love this. If you've never used microbit, you are going to have so much fun playing with this. Hello to Rachel from Alabama. Welcome, everybody. All right. Hello from Philly. Love it. Welcome. Welcome, Andrew from Connecticut. Awesome. You're getting such a good group. I think our numbers are starting to settle in just a little bit. So I'll keep an eye on that. India. We've got an international audience today, Chip. I love this. We usually see that a little bit in our workshops, but I love that when we haven't been seeing it quite as much lately. So this is pretty exciting. All right, I have a few more people joining. That's all I really have to do to make sure we get another batch of people popping in is say, I think we're settling down. And that's just fine. We want as many people as possible to come to our workshops. So perfect. All right. If you're just joining us, hello, hello, welcome. We're just going to get started. You haven't missed anything just yet. So what we are doing right now is just tossing a few introductions into chat. And I'm going to go ahead and kick us off to give Chip as much time as possible. We are super excited to have Chip Kramlich with us today. He is an amazing educator from Georgia, and where he is just, sweating away today in the heat. And we thank him so much for joining us. We are very excited to have his expertise today. We also have a few CodeHS team members with us today on the back end who'll be answering a lot of questions for us and helping support us all the way through this workshop. We have Rachel from Curriculum with us today. Hey, Rachel, she's waving right now. We also have MR from the PD team with us today. Hey, MR. And we have Emily from Support with us today. So thank you all for helping us out today. And let's go ahead and jump in. So Chip, if you want to go to that next slide. Okay, so here come the slides and here come the links. So first of all, if you'd like to go ahead and check out the slides, and you may want to, it might be helpful to have those in front of you. You can go ahead and scan that QR code if you want to see that on your phone or mobile device, or you can go ahead and click on codehs.com/microbit-slides. MR has tossed that link into chat for you. I'll give you just a minute to go ahead and click that or scan the code or take a picture of the code, whatever you'd like. Quick drink of water. You will also get this link to the slide deck in the follow-up email after this workshop. We are recording today, and so I will send out a follow-up email sometime tomorrow with the recording to the workshop and any resources that we use as well. Okay, let's go ahead and go to the next slide. All right. And also, because we have a little bit larger group, and I have a feeling we're going to have more and more people joining us today too, we want to make sure that we get all of your questions answered. Sometimes they get a little bit lost in chat, especially since we ask you to do introductions, or we might ask you to answer something in chat. So if for any questions you have, if you could please add those to the question parking lot, that would be awesome. So add those to codehs.com/microbit-questions. You can also scan that QR code as well. That would be great. Give me just a second to grab that link. Yeah, and if there's any questions that we can't answer during this workshop, that makes sure that we don't lose your question. We absolutely want to make sure we get all questions answered. So go ahead and toss those questions onto that question parking lot, please. All right, let's go ahead and go to that next slide. And we've been doing introductions. So if anybody has not introduced themselves in chat yet, you can sure do that. And if you'd like to give us any other information, that would be great. Do you have any experience teaching physical computing? Have you done it before? Maybe you've done it with a different physical computing device, but you can certainly share anything else that you'd like. We love getting to know our amazing CodeHS teachers. So definitely toss that information into chat for us. And I'll keep an eye on the chat as we go through this intro. Let's go ahead and go to that next slide. Okay, so a little bit about what we're going to be doing today. We have a packed couple of hours for you. We're just working our way through this welcome and virtual check-in. We're actually going to have you enroll in our workshop section shortly and create accounts if you don't have a CodeHS account yet. Then Chip is going to take over from there and talk a little bit about the physical intro to physical computing microbit course. I felt like I really garbled that name. Intro to Physical Computing with Microbit course. There we go. Enunciate, Lori. And then he's going to walk us through some lessons and really let you all have some time to explore what the lessons are using and actually working with some of the emulators. Then we'll actually play with that for a while, have some lesson explorations, some interactive opportunities, maybe a breakout session tossed in there. And then towards the end of our workshop today, we're going to give all of you an opportunity to explore more information about either CodeHS or talking to Chip about the content of the course and strategies to approach that content. So we'll talk more about that in a little bit. Let's go ahead and head to that next slide, Chip. Let's see. If you do not have a CodeHS account yet, please browse out to codehs.com/signup and go ahead and create one. You will want to sign up for an educator account if you don't have one already. And you may not, if you're just signing up today for the first time, you might not have access right away to all of the different teacher things like solutions, but we'll get you verified as a teacher and you'll have all of that soon. So we'll give you a moment there. Well, we're going to leave it on this screen for just a second. I'm going to take a look back at chat. Excellent. We've got a robotics teacher for grade 10 with us today. Let's see. Nancy's done some work with microbits. Awesome. Using the Python language. Good deal. Let's see. Lisa teaches middle school STEM, middle school robotics, middle school, high school tech trends, and high school tech in business. Love it. Awesome. Pablo has experience in FIRST. I love that program. I think that's awesome. Nice. Oh, cool. So Jennifer has been using microbits with Girls Who Code clubs. I think that's an awesome idea. I used to do a lot of Girls Who Code clubs when I was still in the classrooms and actually want to get back to that again. And I think that's a phenomenal idea. It's a great way to develop a lot of interest in computing. Cool. Rachel's adding the microbit unit. Excellent. Love seeing all of this. Cool. Awesome. Heidi, I'm excited to hear you're also a Girls Who Code Club facilitator. and excited to hear that you're getting started with CodeHS. We are here to help you with that. Excellent. Oh, excellent. Chrissy is interested in how to use this with your middle school science teachers. Love seeing that. I think there's a ton of opportunities to integrate microbit into science as well. Stephanie, 20 plus years CTE teacher. Awesome. Welcome. I was a CTE teacher in my district too. And that is some good experience that you are bringing. This is excellent. Nancy, I think we can all continue learning about these things. I know I'm excited to be here with Chip and learn from him today. So this is going to be such a great workshop for us. All right. So let's go ahead and head to that next slide. Once you have your account, or if you have an account, you can go ahead and sign in. And we want you to enroll in our workshop section, please. So MR just dropped this link into chat, so you don't have to type that long one. If you could go ahead and sign into CodeHS, then click on the link, codehs.com/go/62FB6. That would be wonderful. And we will keep an eye out on the back end to make sure that you are getting enrolled in the section. I'm going to take a pause here.
The link in the Google Doc, the same section as what is listed on this slide?
It should be, yes.
Okay.
We can double check that too. If somebody from the team wants to. Okay, thanks, Rachel. Sometimes I've been checking a lot of links lately. So if you run across something that shows up a little funky, just let me know. We'll get that fixed. It gets super easy to get mixed up thinking about which workshop was I working on? Oops. All right. How are we coming, everybody? I'm going to take a quick peek at where we're at with that enrollment, because we really want you to be enrolled if you're able to. I know some people might be in class yet. Some people might have some other things going on, and that's totally okay. But if you're able to, we would love for you to enroll, because then you'll be able to participate. Excellent. We're getting everybody. This is wonderful. If you have any issues, don't hesitate to drop a note into the question parking lot, and somebody from our team will help you get enrolled or help you with any questions that you might have there. So perfect. I think we're getting there. All right, Chip, let's head to that next. Okay, one more link. I thought there had to be one more in here. So this link is important. This is not just an attendance link to tell us you were here, but once you click this link, you will also make it super easy for me to send you a certificate of attendance after this workshop. So please make sure you click this link, codehs.com/microbit-attend. You will get a certificate of attendance for 2 hours for attending this workshop. And I will send those out probably later this afternoon, and they will come from hello@codehs.com. So if you don't see this by end of day tomorrow, drop me an email and I'll make sure to get that out to you. All right. I think you have all probably heard enough from Lori today. So I am going to go ahead and I think this is the next thing we're doing. Go ahead and click to the next slide for me, Chip. It is. So this is the point where I turn it over to our amazing presenter today, Chip Kramlich. Chip, I'm going to let you take it away.
Okay. Hello, everybody. Let me go ahead and reintroduce myself, Chip Kramlich. I currently teach high school. I'm a CTE teacher. I teach various courses. I teach the 2 AP computer science courses, but one of my hobbies, and that's what really got me into this, is combining electronics with computing. I started working through this stuff about 8 or 9 years ago. Started with the Arduino and played with the bare boards as they came out. So I've got a microbuilt right now. I've got a little program blinking on it. The great thing that over the past few years with these devices, and let me explain a little bit what they are. These are kind of like little mini microcomputers, but it's not a real computer like you have in front of you. They are what are called microcontrollers. They're special purpose. They only do one thing. So the program you install on it, that you run on it, that's all it's doing all the time. It just runs your program over and over again. So over the past few years, it's gotten a lot easier to write code. Companies like Microsoft have created a product called Make Code, which is really great. It's a block-based language that also can be done text-based, and that's what we're going to look at today. If you go to microbuilt.org, they've got a link to the Make Code IDE. They also have their own that will allow you to actually write code in Python, but you can also do the same thing with the Make Code editor. So what we're going to look at is the actual course that CodeHS has. It's a quarter long, so those who aren't familiar with a quarter is about 12, 14 weeks, somewhere around there. So if you're doing like in the South, we have our middle school connections courses that run for about 9 weeks. So it would fit within that concept. Now, the microbit is more for that entry level. And the great thing about physical computing is this is a hands-on thing. So unlike kids just typing away at the keyboard, here they get to wire things up, and that's going to give them a little bit more to actually play with, allow them to express their creativity in a much more hands-on manner. So CodeHS has 2 courses. They've got the Intro to Programming with Carol and the microbit. Carol is the robotic dog where you kind of teach it how to actually move around its little world. And then we also have one which is Tracy the turtle. Tracy is more graphics based where you're actually having a little turtle that draws lines and curves. And so what we're doing with Carol and Tracy is teaching some of the basic constructs of programming. Okay, so let's look a little bit about what is a microbit. It's produced by the BBC. They sell for just under $20, but given the chip shortage, they're kind of hard to find. I was looking just before we started the class. Adafruit.com has 60 of them in stock. You cannot get a class set. You got to buy them individually. At this point, their class sets are sold out. But the great thing, as you can see here in the picture, is you can wire up individual components, whether that's like a little servo motor. You could wire up something here like this is a PIR, a passive infrared sensor. You can even hook up LEDs. These are NeoPixels. They are RGB LEDs. Each one's individually addressable, and you can actually have it light up. Now, the great thing with the microbit is it's got a lot of these things built in. You have a 5x5 red LED matrix right there in the middle. You have 2 buttons, your A and B button. And on the back side, it actually has some of the sensors it has built in. Looking at the one I've got here, I mean, it's got a compass, so it can detect a direction. It's got an accelerometer, so you can detect motion in 3 degrees, up, down, left, right, forward, back. It has a temperature sensor, so you can actually do that. It also has a small little radio, so you can communicate from one microbit to another. So start off with just having the microbit gives you enough to actually get started. And then as you get going through this, you can buy the little bit of extra components to actually wire up. And one of the great things with the microbit is the front of it, as you can see here, has these little pads, and all you can do is just using little alligator clips to just actually connect to it to wire up your circuits. You don't need the little breadboard or anything like that. You can just do it with alligator clips. Okay, so now there's 2 versions of the microbit, version 1, version 2. There's not a whole lot of difference between them, and the kind of coding you're doing, this will work with either one. So if you have one of the older ones, it's fine. If you just find a new one, that will work also. And they all pretty much have the same features. Beyond that, they're pretty much the same. Okay, so what the unit has, or the CodeHS course has the following units: the introduction to the microbit, the program control, and then the advanced microbit. Today, we're really going to focus on the first unit and 1 or 2 lessons in that actual unit. Okay, so we're going to look at our first sample unit, setting up your microbit. And this is actually in the CodeHS thing. It's actually in the first unit, it's lesson 2. So your sample lessons, excuse me, a little dry. What it's like to go through these activities, if you're seeing it from a student point of view, what would the student actually see? And I'll bring it up in a second. And from a teacher point of view, how would you actually view this? So I'm going to go ahead and switch over to my other screen. And let's see. Here we go. So this is inside of CodeHS. This is the actual introduction to microbit thing. And this is the student view. And we're looking at here, this setting up your microbits. Now, if I want to with CodeHS, you can actually switch it back to a teacher view. And from the teacher view, you can see things a little differently. You're going to get some extra information. But here, if we click on the little plus sign here, we can actually look at the individual components for this actual lesson. And we always start with most of the CodeHS lessons, start with a video. Some will have a quiz immediately afterwards. This one doesn't. This has a little exploration and then another video. And then we always have coding exercises. Those are the little pens you see. Now, with the microbit, unlike some of the other CodeHS courses, you're not coding inside of CodeHS. This is where you're actually coding outside. But the students will be posting their code back into CodeHS. So we're going to be using CodeHS as the LMS from this point. Okay, let me switch back to the presentation. Okay, so physical computing is creating or using devices that interact with the world around them by using the sensors to gather information. And that's what we've got with the personal infrared sensor. This is a motion sensor. If you have a security system, this is what's inside that motion detector. It just detects movement, changes in infrared. You've got other sensors. Again, the device has the accelerometer. It can detect movement. It has the compass. It can detect direction. It can also detect temperature. Now, you can buy a bunch of other different types of sensors that are available and actually connect all these up. They all kind of work the same. They're either going to give you some kind of feedback that's either going to be like an on or off kind of thing, like the passive infrared, or they'll give you some measured value, like a temperature sensor. Now, we can program the microbits to interact with the world around us with these sensors, as we're saying here. And this is the great thing. Students get to interact from a device with their actual environment. So let's take a minute and really look real quick at the MakeCode editor. Let me go back over to that screen and give you a brief introduction to what we're looking at. So here is, oops, that's the MakeCode stuff here. This is MakeCode for microbits. This has gotten a lot better. Microsoft has gotten a lot better at actually getting this site up and running. This is FERPA compliant. They don't have user IDs. Students are not logging in, so it's not storing any user information. The key caveat, though, is it stores it part of your local profile. So if students are working on one machine and move to another, their files aren't going to be in the same spot. That's where students will need to actually download their programs if they're going to use it on a different machine and upload it from there. You have the main area here, which is where all your projects are. I've got a couple here that I've got. They do have some good tutorials to go through. They're definitely worth going through. They've got some tutorials for the version 2, some videos you can go through, games you can play with it. Again, it's a very interactive kind of device. So definitely worth looking at. But if you want to start a new project, you just click on new project and we'll go ahead and give it a name. I'm going to call this 1.2. And this is our editor. Inside the editor, what we can see is we have our palette, where we can collect our commands. We have our simulator over here, and this is our editor. I'm going to switch it over from blocks to JavaScript. Now, for those who are teaching maybe the younger kids, elementary or maybe even starting something with middle school, you may want to start with blocks if their typing skills are not that good. So you can always go back and forth between blocks and JavaScript without a problem. So I'm going to switch over to JavaScript, and we can see we've got our code here. Now, one of the great things about this is if I want to actually just add a command, I can come here to the blocks. If I don't remember it, it's like, okay, I want to go ahead and maybe just have it show a smiley face. So I do show icon. Oops, I'm putting it in the wrong spot. And put it up here in the forever. And once I've got my command there, I come over here, I can hit play, and the simulator will actually run it. So the simulator is really going to help us. It's going to make it where you don't need the devices right away. And one thing I use the simulator for is I make sure the students understand how to use the device in the simulator before they actually use this devices. I mean, if you've got a class set of 25 and you have 25 kids and all of a sudden one gets broken, that means somebody's not going to have access to the physical device. This way you can make sure, okay, testing the simulator first. Once you got the simulator working, then we can load it onto the actual device. So it's fairly easy. You just click on the palettes and it gives you the commands. You can work from there and just drag them over. If you remember your commands, you can do them fairly simple. Like for putting a single dot up there, I can just plot X, Y, and just do it. So you don't have to actually remember exactly what the commands are if you're actually typing them in. Okay, let's go back to the presentation. Thank you. Okay, not gonna put too far. Let me just go back real quick. There it was. Yeah, okay. So here, setting up your microbit. What we're doing is we're going to be using JavaScript. JavaScript is a great multi-purpose language. It's used in a lot of devices, but I will tell you Python's coming along strong. So if you're more comfortable with Python, you can actually use Python inside the MakeCode editor. Again, going to makecode.microbit.org will take you to the actual IDE. So let's go ahead and look at some of these exercises. So if you go ahead and go to the actual workshop course, go to lesson 1.2 and setting up your microbit. I'll go ahead and follow along in the lesson, going back to the actual CodeHS lesson. Okay, so if we look at CodeHS lesson, and I'm going to go ahead and go to the four corners. This is going to make the assumption that you've gone ahead and gone into makecode.microbit.org. So you're going to write a program that will solve the following task. Turn on the LEDs in each corner of the grid. Head to makecode.microbit.org. Write the code using the commands you've learned. Now, going through some of that, that's part of what we can do with these previous ones. I'm going to go back to this one, exploring LEDs. Now, my CodeHS is really good at providing some worksheets that go along with the assignments. So I'm just waiting for it to come up all the way. But with this, we've got certain commands that we can use. And while I'm waiting on that, let me go ahead and jump over here. So the one we really want to work on today is LED plot. So LED plot is going to actually turn on a specific LED in our grid. Now the grid is a 5x5 with the top left corner being 0, 0. So unlike the coordinate plane in mathematics where your origin is at the bottom left, here our origin is in the top left with Y increasing as we go down. So we have 0, 0 up here, and then they increase, the Y increases as we go down, X increases as we go across to the right. So if I wanted to turn on those four corner lights, I need to turn on those specific ones. It's a 5x5 grid with it starting at 0. So our indexes go between 0 and 4. That will give us a total of 5. So that first upper left corner would be 0, 0. And then if I want to go over to the right, I got to go over and I can get to that last one. And the bottom one is full X and full Y. So I'm going to let you guys work out what that actual value is and go from there. So once you've got your code written here, you can actually run it. And again, try to keep it all inside the forever. So if I just here and do LED.plot, and it will actually help you out. 0, 0. And then if you run it, you'll see it turns on one light. So this is one way you can actually figure out where the actual items are. If we change the number, let's say I go to 2 and 3, and I run it, we can see where the grids are. So just running this little exercise here will get you familiar with the LED grid. So going back to CodeHS, hopefully the documents come up. No, it didn't. Let me refresh the screen and see if it comes up then. There it goes. Okay. So setting it up, how to do that. And again, talking about using LED plot. And so students would just fill this out as they go through it. They work through, they play with it using the simulator, and they can then figure it out. And then based off what you've noticed, can you plot out the rest of the grid? What are all the coordinates from this? Please be aware they are in X and Y format, not row column format. So always, when you're working with this, think X, Y. And then we get to another command, which is pause. Because this device is what's called a microcontroller, it runs at a specific speed. So if I turn something off and turn something on without a pause, you won't notice it. It's going to be faster than the human eye can detect it. And it'll just look like it's either always on or always off. So we put these pauses in to slow it down. So that way we can see it actually blink. Like here, for mine, I've got it pausing for half a second. Now, the amounts you're putting into the pause are actually in milliseconds. So 1,000 milliseconds could be equal to 1 second. 500 milliseconds is a half a second. So just splitting it up from there for your time. Okay, so let's move on to the actual lesson. So 4 corners. The first lesson is to get it to light up with 4 corners. So hopefully you have enough knowledge now to actually using LED plot to actually light up the 4 corners. And they'll just stay on if you're just doing it, and that's fine. And then the next lesson is blinking first letter. Now, there is something called show string. And let me go to here and I can show you where it is. So if you go under basic, you have show string. If you just put in a single character here, it'll just display that one character. If you put in multiple characters, like a word, it's going to actually scroll them across one at a time. So one of the features that's built in. So using show string to actually get it to actually display information. That's the second exercise. And then the last one is blinking diamond. So getting it to actually do this. Now, there's other commands that you may want to play with to get this. We're going to do a breakout session in just a little bit. We'll put you in rooms and you can work with the rooms and work through these exercises. So let me go back to the presentation and we'll continue on. Okay, so we've gone through this. Now it's time for you guys to actually get together. So you'll find the document here, microbit exploration. We're going to give you your breakout group, and then within your group, you'll be able to work through these activities. Me, along with the other CodeHS people, will be there to provide some assistance to you, but go ahead and give it a shot. Now, as we see here in 3A, the person who lives closest to Nashville will be the person who's taking the notes. So when we come back together and discuss it, they'll have questions or anything you guys found really interesting. Again, try the exercises. If you think you understand it really good, play a little bit more. This is the fun thing with the microbit and other physical computing devices. Once you understand how they work, you really can let the students just go and explore a little bit more and have a little more fun. Okay, so what we'll do, go to breakout groups, and then we'll get back together in about 10 to 12 minutes.
So go ahead and make sure you grab that link that MR threw into chat, and I'll go ahead and open up the rooms. I do know that some people might be with students right now, so if it's hard to go to a breakout room, no worries, but we hope you can join. Let's make sure, let's double check that folder real quick before I open up the rooms.
I just updated that link, so you should have access now.
Thanks, Rachel. That was very fast. I appreciate that. Go ahead and try that again.
Good now.
We're good? Okay, cool. All right, I'm gonna go ahead and open up the rooms. See y'all in a few minutes. If anybody has any trouble joining a room, just let me know.
Okay, so what we did with there is we really went through these lessons and we explored this grid. I know in one of the rooms, somebody was asking, like, they were used to using the blocks and didn't know where the plot function was. For all of them, whether you're doing JavaScript or block, it's underneath the LEDs. Basic just does the basics, which is really more set for some of the younger kids. But again, if you're doing something that's a little more advanced, working more with a little more mathematics, or you want to do something that's not just clicking little buttons where you're working with X and Y, plot is the way to go. So as we saw, 0 zeros in the top left, and with the box they've got here. So if we look, we're going down 1, so our Y value is going to be at 1. And if we look at our X, we're going over 3, so 1, 2, 3, and down 1. So this point would be 3, 1. Okay. So the next one, we're looking at this exploring. As we can see again, I think X and Y over 1, down 4. So we're at 4, 1. Now, going through some of the stuff, you write a program that will turn any 2 LEDs on at once for 1 second, and then turn them off.
Would you share your screen, please?
Pardon?
Would you share?
Oh, I'm sorry. I thought I was sharing. I'm really sorry about that. There we go. Okay. There we go. Okay, so this is going back through it. So here, unplot and pause.
Thank you.
So when we deal with this, again, plot's going to turn it on, unplot's going to turn it off. And as I said earlier, if you don't have a pause in between, it's going to happen so fast you won't see it. So if I did a plot of 1 point and then immediately did unplot, it would show us off. So you want to pause in between. And what this pretty much does is allows things to blink. So we can turn on 2, you just LED plot the first one, LED plot the second one, do a pause for 1000 milliseconds, then LED unplot the first point, LED unplot the second point. It can be either way, and that will give you your 5 lines of code. So it's a fairly simple program to write, as we can see from here. Plot 1, plot 2, pause, unplot, unplot. Now, with this not being in forever, it just turns it on and then turns it off. The forever command is really interesting. If you've worked with any kind of microcontrollers, or you've worked with like the processing or P5.js languages, it's the same thing as their loop function. These devices, if you just turn it on and then turn it off, that's what it is. It's done running the program and it just stops at that point. But we want them to keep going. If I'm reading from sensors, I want to keep reading from sensors forever. So the way this functions is it is an endless and infinite loop. And if you've taught programming for a while, you explain to your students, try not to write an infinite loop. Well, when you're dealing with microcontrollers, you need the infinite loop. So that's why they've got this basic forever right here. We want it to keep reading information. Now, these devices run as long as they've got power or until you hit the reset button. Reset button is just going to restart the whole process over again. So if you notice the difference between this slide with the plot, unplot, and the pauses, here we just paused in between and then we did unplot. On this one, you need to plot the pause, the unplot and pause. That second pause is needed because you have to, again, give the human eye a chance to see what's going on. We need to turn it on, wait for a second, turn it off, wait for a second. Otherwise, it's turn it on, wait for a second, turn it off, which then means the turn it on is going to come immediately back on. You'll never see the off piece of it. So something teaching when you're working with your students, that pause is necessary after you turn it off so you can see that it is actually off. And if you look, you see exactly what it would show up in the simulator. Just a little blinking light right in the middle. And it runs forever. Again, if you didn't do it forever, it would just turn on and then turn off. Okay, so this is our follow-up based off of it. So LED screen coordinate system, again, the origin is in the top left. X increases as we go to the right, Y increases as we go down. This will help if you ever go into computer graphics or teach computer graphics, whether it's P5JS processing or even the JavaScript graphics farther on in there, you're going to have the same coordinate system. So introducing it with something like the microbit is a great way. Students get a handle on it. They just have to remember this is kind of flipped vertically from what they've been taught in math. So the center again, we go over X, we go down Y, so we're at 2, 2. Here, go over 1, down 4, so we're at 1, 4. And we use the plot command, it turns the LEDs on. Unplot turns them off. Now these are similar, other microcontrollers use similar languages. But again, we're dealing with, for many of you have programmed for, in a Boolean system, or binary system. It's got one of two states. It's either true, false, on, off, yes, no, 1, or 0. Based off the language, it may be something in another form. Here we're doing with plot and unplot. And pause, we need to let the human eye see things. This computer works faster than we can actually see things. So if we don't have the pause, we don't see the change. And forever, again, if we don't put it in forever, it just happens once and stops. Forever, again, these devices are running constantly. As long as they're plugged in, they're going to run the code. So when we're collecting information from sensors, or we create a little sign, we want that sign to keep broadcasting, keep showing, and that's why we want to use the forever loop. Okay, so we're going to work through our reflection here. We've got a Padlet set up. Lori, do they have the link for the Padlets?
Yes.
Yep,
And
it's
we're
right there.
just-
It's right there in the chat.
Perfect. You'll also find it in this lesson as well. We added it to the end of the lesson. So if you're in the workshop section, you can find it there too. But just as easy to click that link in chat.
So going from here, hopefully you guys can see my screen with the Padlet up. How do we make an LED blink on our screen? And then how does the exploration portion of a lesson impact student learning? So when you let them just go out there and explore and do it, they're probably going to be able to do things a little differently. Now, quick question is, does the order of plotting and unplotting matter? Like here, we did plot 4, 2, plot 2, 3. Do I actually need to unplot in the same order, or does it really matter at all? That's something you can have your students explore. Maybe they turn them on, they turn on 4, 2, they turn on 2, 3, and then they turn off 2, 3, and they turn off 4, 2. So allowing them to do this, how does that actually impact their understanding? Going from just turning on an LED versus using the forever loop and having it constantly do it on and off. And this is something with most computer science courses. I go in first day with my new students, as I explain to them, you're going to make mistakes. Your programs are not going to work correctly the first time every time. I still write code that does not work the first time. But learning from your mistakes is the key thing. Understanding, once you see what broke, do you have a way of fixing it? And then once you understand how to fix it, can you retain that information and add it to that library of algorithms you're developing in your head? Understanding that matrix, understanding it's different than what you've learned in math. Again, giving them more ability to be creative. They love that. And trust me, after this first lesson, they're going to be sitting here doing more than just lighting up the four corners. They're going to be sending messages, putting text down there. Once they get their hands on it, it's like if you've ever seen students when they first start playing with Minecraft. It's kind of like that. They're going to get to explore and actually work through it. And again, working through problem solving and debugging, but hopefully doing it in an easy, safe environment. You guys are giving a lot of good ideas, a lot of good feedback. I'm going to jump back to the presentation. Okay, let's move on a little bit. So when you're actually in CodeHS, you'll see from a teacher point of view screens like this, where you can see how the lesson is laid out. Typically the preview, that's the eye, you can view it as a student does. There may be handouts, you can actually lock out assessments and do other things. So from a teacher point of view, you'll see this for the resources portion. Okay, so there is another lesson. We're not really going to go through it as a group, but this is lesson 4, dealing with variables, or 1.4. And from this point of view, again, from the way it's laid out, as I've said, there's always a video. This time there is a quiz. There are notes that students can read through so they can understand what that coordinate system is, how to use variables with it. We have free response questions. Connections are links to other things. So here, exploring the microbit pins, the little pins at the bottom of the board. Another video for following up, and then we have the exercises. So here, that pseudocode exercise, the exploration activity. Oops, go back. And so, let me think of how this. I like the question, but we just don't want students to run through the video and run through CodeHS. We do want to actually add it in. And part of the whole thing is dealing with what a lot of us have to deal with now, which is how to teach this to different students. Do we put them in groups? Do we do it individually? Let's say you have a limited number of microbits. How do you group them up? Now, when it comes to programming, one of the great things that you can actually use is what's called pair programming. And this will work fine for this. So you could actually utilize that as part of your programming differentiation. And again, if you check out the chat, they've put in the link for the variables lesson. So if you want to look more at it, I personally do not assign programming assignments for homework, because when students get stuck, they tend to get frustrated. And if they're at home getting frustrated, they come to school in a different mood. So I like to be there as they're working through it. And for most of the stuff, it can be done within a normal 45, 50-minute class period. So time-wise, it's fine. And again, you can assign them in pairs, groups. There are ways of working through that. They can actually share code. CodeHS has a way inside their editor to actually have them work collaboratively. Here with Make Code, they don't really have the collaboration. They'd have to work through one computer. Okay, so we have one final Padlet, planning variables. So how would you approach each portion of the lesson? We have the videos and the slides. So if you've never used CodeHS before, pretty much the video goes through, and then it follows a set of slides that students have access to. Again, there's always the quiz for check for understanding. And you've got the other portions of it that go through the exploration, which is them actually looking at code and testing it out, and then the actual exercises. So, and they've got the Padlet posted in the chat, so you can go ahead and do that. I'm going to go ahead and open that up here. Okay, good. Now, I personally show the video to my class, but the nice thing also is if a student misses that class, they make it up, they can always watch it on their own. I typically do, as you guys done here, let the students complete the questions individually, but I've also had some lessons where we discuss the questions. Based off the unit, it may be, okay, let's go ahead and look at the questions, have a class discussion about them, and then let them actually submit their responses. Yep, another way is just showing slides. I've had a few students who told me they prefer not to watch the video. They'd rather listen to me talk and go through the slides. So that's something else you could do. Now, the key thing is the exploration. Those are the exercises, and I'll try to bring one up here so you guys can see what I'm talking about. This is the problem where if you let your students go on their own with it, they tend to go in a wrong direction. CodeHS will have some example code, and this is the one of the issues you got is students sometimes will just breeze through it and they'll just run it and they won't really look at the code. But looking here, let me go ahead and switch to this. Here's the exploration portion, where they got this, talk about the materials, the alligator clips, one LED and one resistor, and they're just wiring it up. So here they go through this, they go through the instructions, they write it, and then they look at this new command called digital write pin, and see how it works. Now, as long as they're following, they're not going to destroy anything as they do it right. So it shouldn't be too much. And I think you can even, you can use Tinkercad and do it with that, and that will let you actually wire it up inside of another simulator and do it if you don't really trust some of your students with the actual device at this point. But they can go through this. So going back to the Padlet, doing the exploration, how would you guys handle that? Yeah, I like your thing with having somebody write pseudocode and then give it the other one. That's one of the great keys. I teach a course here at Georgia State University to teachers who want to become computer science teachers. And it's dealing with the whole concept of ambiguity, writing it to make sure it's understandable by somebody else. Well, it's trying to get them to understand how to write it so it's understandable by a computer. Okay, good. Yep. You guys are getting some good responses. Let's see. We'll move on in just a second. We're getting close. Okay. Let's go back to the. Okay, so moving on. Under the required materials, again, when we deal with CodeHS lessons, they do talk about what you need. So here, and if you bought a kit or class set from some things, these kits have a lot of these items. So you can also include kits with sensors. You can buy a box of sensors like Amazon and whatnot, and you can use those with the microbit. So there's a lot you can actually use there. Resources, again, what resources are needed. Typically, this will help you with some of the information you may need to fill out for your lesson plans. Okay, so we're going to take a little bit of a break and then we'll be right back with other things. So if you need to take a little bathroom break, get some water, give you guys about 5 minutes and we'll come back from that point.
we'll get started with the remaining time with our workshop in just a minute or so.
I was just writing in the comments, something's come up here at school. I'm in my classroom
Okay.
and I can't stay for the rest of it. I've got to go deal with some stuff. So I'm sorry, and I will follow through with the slides and your recording. Okay.
Sounds great.
All right. Thanks.
Thank you
sorry.
Oh,
Thanks for
no
coming.
worries. Thank you so much for coming. We definitely understand things come up, so that's why we record. No worries.
Thanks.
All right. Okay, everybody, we're going to get started with our breakout rooms in just a moment. Chip, can I have you go to that next slide? Chip might not be back yet, so we'll give him a moment. Let the poor guy have a break. So there's going to be 2 breakout rooms for you to choose from. The first room is going to be to join Chip and chat about the curriculum, chat about the course, and all of that. And so that will be your first option. And just double checking a couple things here. Okay, so that'll be your first option. And the other room will be teacher tools and some resources. And it'll be a pretty high level overview. But if you've got some questions about the CodeHS platform, I'll be doing a quick demo of some of the tools that you have access to in the platform. And I'll talk a little bit about some of the free tools as well as some of the tools that you'll have access to on the Pro plan. So those are going to be our 2 options. And I'm just taking a quick look, and it looks like we might have had a few internet issues. I know Chip was having a couple of issues with the internet earlier today, and so I think we might have lost him, but he'll be back soon. I have no doubt he's actually trying to get back in as we speak, so we'll be patient with him. But go ahead and think about which room you will want to join. So we're going to try to get Chip back as soon as we can. He just sent me a quick note that says he's trying to get back in. He just lost power at his house, and so he's going to be doing the best he can to get back. Shoot. Everybody sit tight for 1 second. I'm going to just send him a quick note. Okay. All right, so we'll keep an eye out for Chip in case he is able to get back in. So CodeHS team, let's keep an eye out for him if he pops back. So our plan for now, oh, no worries, Steve, just saw a quick message. If you do have to leave the session, no worries. We're going to go ahead and keep going with the last 40 minutes or so. Looks like we have Chip is back.
Chip came back.
That is impressive. We'll give him a moment to go ahead and get settled in. Hey, Chip.
Yeah, I'm on my phone because I don't. Power went out.
Best laid plans. I have been there for that as well. So, all right. So here's our plan. I think we're still going to have our 2 breakout rooms. Why not? I think we can still have a great curriculum chat with Chip, and he's on his phone. So we are just like in the classroom. We are ready to go when something happens. So I'm going to go ahead, open up the breakout rooms. Those of you who want to join Chip, and I don't know who wouldn't want to join Chip, you can jump in his room. It's just called Curriculum Chat when I open that up. And anybody who wants to see a little bit about the platform, you can go ahead and join Teacher Tools room. And we'll go ahead and open that up right now. opening up the rooms. So you have the opportunity now to choose which room you want to join. I will be in Teacher Tools momentarily. I'm going to hang out for a moment, make sure people can get where they need to go. Chip, feel free to join your Teacher Tools room, or I can add you. It might be easier since you're on your phone.
Go ahead, add me.
Let me get you shifted over there. Bear with me 1 second. Okay, everybody else, go ahead and join a room. I will be in Teacher Tools momentarily. And I'm going to go ahead and hit pause on this recording. There we go. Forgot we shut that off when we headed out to the breakouts. All right, so a few more resources. If you are excited about CodeHS and would like to do more, we would love to invite you to apply to become a CodeHS certified educator. I was definitely one when I was in the classroom. You get invited to a few meetups, some special training events. You might get some swag. So definitely some cool things with that program. So I would highly encourage you to go ahead and check out that program. If you haven't joined our Facebook educators group, I definitely recommend that you head out and join that group. It's a really good active group. So you'll want to check that out. If you've been, if you're curious about how your skills stack up with CodeHS, go ahead and check out the CodeHS micro credentials as well. We've got some cool teacher micro creds, and we'd love to see more of those credentialed badges out there on our emails when we see those come in. And definitely check out more CodeHS and teacher trainer workshops that are coming this summer. We have a huge list right now on codehs.com/freepd, and more are going to be added. So keep an eye on that. If you can't come to the workshops in person, we always send out the follow-ups to everybody who's registered. So feel free to register for any and all that you might like. Our next workshops will be next week. On Tuesday, we have Teaching Fundamentals of Cyber for new CS teachers. Do not let that name fool you too. If you just want to see an overview of the Fundamentals of Cybersecurity course, just come on over. We would love to have anybody there to explore the fundamentals course. The cyber courses are some of my favorites. If you have not taught cyber, I would highly encourage you to check this out. I think this is a hugely engaging way to get kids excited about computing, computer science, programming, cybersecurity. I absolutely love the topic. So I definitely encourage you to check that out. Also, next week, we have Teaching Intro to AI and Data Science. Those are more Python-based courses and a little bit more advanced. Some of our favorite courses, again. So definitely register for that. And we have another one next week too. Game Design and Unity is next week. So 3 of them coming up next week and so many more to come after that. Chip is going to be doing another workshop for us later this summer on physical computing with Arduino. So I definitely suggest you sign up for that one too. And one more thing, we would love to know what you thought of today's workshop. So if you could take a moment to fill out the survey for us, codehs.com/workshop survey. We would so appreciate it. This absolutely helps us know what we can do, what we can bring to you. We love to hear your feedback and know what else you need to see from us. So take a moment, tell us how we did and what else we can bring to you. We appreciate it very, very much. And that is going to take us to the end of our workshop. I am not sure if Chip has been able to hang. Oh, there he is. I see Chip. Chip has been able to hang on in the dark, but he's with us. Yes. So I'm glad because I want to make sure I say thank you to Chip. This has been immensely informational, inspiring. I've come away with so many good ideas. I hope you all have too. I know every single time Chip does a workshop for us, I immediately have to go back and try stuff. So that is how today is feeling. And I'm going to have to wait until tonight. So I'm a little bummed about that, but it's okay. I'll hold on till tonight and I'll go try stuff with my microbit. But thank you so much, Chip. This was awesome. And we so appreciate everything you've brought to us today and all of it. So thank you. You are amazing. We appreciate it. And I want to thank the whole CodeHS team for being here today, because I know I could not do this without you. You all are so fast. I don't know how you find those knowledge base articles that fast, and all of your support for all of the teachers today. Thank you all so much for being here too. And lastly, I want to thank all of our amazing teachers who joined us today. We know you're busy. For some of you, it's summer break, and we know that you need your break. It's been a year. For some of you, you're still in school, and our hearts go out to you if you are still in school. We hope you get to take that break pretty soon. And thank you. Just thank you for being teachers. We know it's been a crazy year, and we know that. We appreciate you. We appreciate all you do for your kids. And thank you. Thank you for being a teacher. And thank you for coming today. Have a wonderful rest of your day. And we look forward to seeing you at the next CodeHS workshop.